Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fourth lecture of Module 3 on mechanical attributes of geoground and geomaterial. In previous lectures we have discussed about engineering properties of rocks. In these lectures we will learn about geotechnical characteristics of joints and approaches for rock mass classification. In these lectures, we are going to discuss about joint and approaches for rock mass classification. In these lectures, we are going to elaborate about concept of joint, geotechnical characteristics of joint, and approaches for rock mass classification. Friends, as you know, the rock mass characteristic is a part of crust. Crust is made up of rock mass on one side, on another side it is made up of rock strata and some weathered material soil, which we have already discussed. Today we are going to concentrate only on rock strata, and rock strata is integration of rock mass. Rock mass, as per our discussions, is consisting of two things. One is a joint and another is intact rock. This integration of this rock mass responsible for formation of rock strata or rock stratum, and plural is rock stratum. As the joint is a part of rock mass which is responsible for formation of rock strata, and rock strata responsible for creation of some geoground, it means it is important to know about the rock mass. Here we can see the rock strata consisting of intact rock as well as number of interfaces present here. About this weathered material and the end product of weathered material we have already discussed. As far as rock mass classification is a concern, so we have concept of rock. Rock is a solid naturally occurring aggregate of minerals exhibiting certain chemical composition and in our view possesses certain mechanical and hydraulic property. So for categorization of rock strata we have qualitative approach, we have semi-quantitative approach, and we have quantitative approach. Earlier it was limited to qualitative, and now we are trying to quantify the things through the quantitative approach. If we are going to anyhow manage to quantify the descriptive geological information particularly related to joint, we have concept any strata consisting of some bedding, some fracture, some discontinuity, some interfaces. I think that none of the strata is without such type of interfaces. So for rock mass categorization, we have two approach, single parametric approach and multi-parametric approach. Both single parametric and multi-parametric approach both are confined to joint characteristic. This joint characteristic we are considering under geotechnical or engineering geological characteristic of joint or geotechnical characteristic of joint. For this engineering geological characteristic of joints, we have selected number of parameters under the geotechnical heading, geotechnical parameter. One of the most important parameter is here number of sets. We are utilizing as joint number. Then the frequency of joint, then orientation of joint, then the spacing of joint, then persistence, then about the opening, then roughness, and a special category of opening is aperture, then filling. These parameters concerned to joint responsible for rock mass categorization. Therefore, these parameters are helpful in rock mass characterization. As far as in our previous discussion we have discussed, the rock strata or rock stratum is consisting of some interfaces. Rock stratum is consisting of some interfaces like bedding planes in case of sedimentary rocks, or some fractures in case of igneous or metamorphic rocks, some foliations, some lineations. Various types of these interfaces present in rock strata or rock stratum. As these interfaces are going to influence the strength or mechanical as well as physical attributes of this strata or ground. Therefore, it is a very important requirement of this approach, engineering geological approach, to anyhow quantify the descriptive information concerned to geological ground or geological strata or geological beds. For such categorization, we have selected this number of parameters such as this joint number, joint frequency, or means number of set, then frequency, then orientation, then spacing, then persistence, then opening, and a type of opening is aperture, then roughness and fillings. So one by one we are going to elaborate, because without such consideration concerned to different features of joints, we are unable to help in rock mass characterization, because rock mass characterization is basically depends on characteristic of joint as well as intact rock. So here the characteristic of joint is playing role, important role for rock mass categorization in comparison to the mechanical or engineering properties of rocks. Friends, you can see here the number of interfaces here, these interfaces, these interfaces, these are not of a same origin and belongs to different sets. You can see with help of this figure here, one set, here you can see second, you can see third. So in this way you are going to define number of joint sets. About orientation of joint, before we are going to discuss about the orientation of joint, we are going to analyze about the frequency. Frequency means how many numbers of joint present in, how many number of joint, frequency of joint is equal to number of joints. Without considering the set, concept of set. Another important thing in geology, we are always stressing about this orientation of joint, and this orientation of joint is simple. It is attitudes of the joint in space that defined in terms of two things. One is strike as extension, and important is a dip. You can see here the dip of this features are this plane. One thing we are going to see about the orientation with respect to this horizontal, and we are going to measure in vertical plane. Another thing, direction. So orientation of separation or joint is the attitude of a joint in space, and it has two components. One is dip amount or amount of dip. You can see here this through this diagram also. The amount of dip, what is the inclination of this plane? Inclination of this plane, if we are going to measure in this plane, if we are going to cut this face, then we can see the amount of dip. And dip direction, in which direction this plane is dipping with this amount. So the dip amount is very simple. It is an angle between this horizontal and inclined plane. You can see one plane here. If you imagine here one plane here, and so angle between these two, this plane and this plane, is recognized as dip. And the direction in which this plane is dipping or the surface is dipping is recognized as dip direction, and generally the dip direction we are going to measure from north. In this way we have here shown in different way to explain you. Here you can see this plane, if we are going to extend, and this plane is running which is containing this interface, we are going to measure this amount, and in which direction we are going to measure from north. So the dip or orientation is equal to dip, and dip is simply not defined by one term. Dip is amount plus direction. For example, 30 degree north, 45 degree west, means this plane is showing inclination of 30 degree with respect to horizontal measured in vertical plane. Always we are going to practice the measurement concerned to dip amount is always we are going to utilize as vertical plane. In this section we are going to measure this north 45 degree west, from the north 45 degree west, in this direction this plane is dipping and dipping with this 30 degree. Dip is a very important from our geological point of view to measure the attitude of joints or measure the attitude of any features present in rock strata, either bedding, either lineation, either foliation, etc. If any strata is traversed by, suppose in vertical section we are going to take this, or we are going to take this zone, any plane, then we can see here 1, 2, these two joints is going to divide this surface 1, 2, 3. So spacing means the distance between this normal distance between these two. Suppose here J1, here J2. So distance between J1 and J2 normal is joint spacing. Joint spacing is a perpendicular distance between adjacent discontinuities or joint belonging to same set. This set running parallel to each other. So if the distance between these two consecutive joints is less, it means number of joints are more. If the number of joints are more, it means if the number of discontinuity plane going to traverse this, then this block or this strata is going to show reduction in strength response. So spacing is more. We can say that spacing, if spacing value is more, then the number of joint is less. And if spacing value is less, then the number of joints more. It means spacing is inversely proportional to the frequency of joint. And if the spacing is less, then such type of strata going to show less strength in comparison to the big block. Suppose we have this level of spacing. One interface is here, one joint J1 and J2 is here. It means this zone representing this whole block, it is almost intact in nature. Intact rock is going to show more strength. So spacing we are utilizing for partially quantifying this. On the basis of joint spacing, we have categorized different type of classes based on the value of joint spacing. If the spacing means the distance, perpendicular distance between these two consecutive joints of the same set is less than 20 mm, it is extremely close. And if ranging from this 20 to 60 mm, it is very close. 60 to 200 mm, close spacing. 200 to 600 mm, moderate spacing. And then 600 to 2000 mm, wide spacing. Then 2000 to 6000 mm, very wide spacing, and more than 6000 mm is extremely wide spacing and goes to another zone. So in view of the joint spacing, we are able to categorize different type of joint based on spacing. Next parameter is persistence. If you see any rock strata or any block in 3D here, in 3D, the joint may be extended up to this distance, may traverse through this zone, may be limited to some 50%, may be limited to only 25%, or limited to 5%. If this type of 5% extension is available, here 100% extension is available, here 50%. So this persistence is also going to influence, because the extension of this zone is limited and major part of this block is away from this traverse. So persistence is the joint trace length as observed in an exposure. You can see here this persistence, this persistence. So persistence is indirectly extension of joint going to cover. On the basis of this persistence, we are going to again categorize. If the persistence is less than 1 meter, it is very low persistence. And if it is ranging from 1 to 3 meter, it is a low persistence. And if 3 to 10, medium persistence. And if more than 20, then very high persistence. In this way, we are able to categorize joint based on persistence. So we have categorized based on joint spacing. We are able to categorize different group based on persistence. And then next is a very interesting thing. If you are going to open this any joint surface, here I try to draw with help of this cartoon, rough cartoon. If you are going to open this part, A part, from B part, then you can see different type of features present on the surface of the joint. It may be this type, it may be linear type, it may be very erratic type. So considering all the possible type of joint unevenness or irregularities, we are going to categorize the joint roughness broadly in three categories. Broadly in three categories. So first, you will know, measure of unevenness or irregularity present on surface of joint is known as joint roughness. The joint roughness can be broadly categorized in three categories. It is easy for understanding. One is stepped, another is undulating, and third is a planar. Further, these steps can be divided in three categories: rough, smooth, slick and sided. The same thing we are going to repeat here: rough, smooth and slick and sided. Then same here: rough, smooth and silica-sided. Friends, you can easily understand this. Broadly, roughness can be categorized in three broad categories: stepped, undulating, and planar. Then the steps can be divided in further three categories: rough, smooth, and silica-sided. Similarly, undulating also rough, smooth, and silica-sided. Then planar also rough, smooth, and silica-sided. You can see here view features I have taken from book. This overall appearance of this zone is stepped in nature. You can see stepped in nature. But it is rough. Another is stepped in nature but is smooth. And another is here silica-sided. Silica-sided is geological structures formed in case of the fault slippings and other some linear markings. So this type of silica-sided. So step overall appearance is stepped in nature, but it may be smooth, it may be rough, it may be smooth, it may be silica-sided. Similarly, for undulating, you can see this rough but undulating in nature. It is rough but overall undulating in nature. It is smooth but undulating in nature. It is silica-sided but undulating in nature. Similarly, here planar, it is rough but overall features is planar, and it is smooth and it is silica-sided. So in this way we are going to categorize joint in 9 categories. Many researchers have done a lot of work on concept of the joint roughness, try to quantify the joints. This concept I have taken from book written by Bhutkuru and Matsuyama in 1994. Another school belonging to Barton et al., they have suggested, Barton and Chobe, 1977, they have suggested 10 type of roughness profile based on laboratory work. We will discuss in our future classes. Next aspect is joint opening. You try to understand carefully, any opening present at the exposure means can be visualized on the surface. So distance between these two points is recognized as joint opening. It is open space between adjacent rock block. This block A, block B. Here we are not going to see these downward features. If by any means, if we are going to measure perpendicular distance, means considering this whole extension. Previously I have shown here this joint, if the joint is like this and we are getting here open space, it is a joint opening. However, in such case where we are going to measure the perpendicular or normal distance between this block A and block B, where the joint is going to separate, so this distance we are recognizing as aperture, joint aperture, perpendicular distance between adjacent block of an open joint. Next parameter is a joint filling. The material, some of the materials filled in spaces present between two blocks of rock separated by this open joint. It may be loose material, it may be saturated loose material, it may be mineralized material, it may be clay material, it may be carbonate material, it may be siliceous material. So the strength response of such filling materials playing important role in estimation of the strength response of such type of joints. So joint filling is also playing very important role. Friends, this joint related material you can well study about the book related to rock mechanics written by Bhutkari and Matsuama in 1994. Then engineering geological book written by Well, written by the Waltham and Koshavulu, etc. In these lectures, we are going to conclude. As you know, rock strata is a consisting of intact rock and joint, means integration of rock mass, and the joint result critical problem in strength estimation of the rock strata, because any interface present in rock strata is going to influence the strength response of ground or rock strata. The joints can be geotechnically characterized on the basis of number of parameters which we have already discussed related to various features of joint. The geotechnical characteristic of joints are significance in rock mass classification, and we have two single parametric and multi-parametric approaches for rock mass classification. Dear friends, in this class we have discussed about geotechnical characteristic of joints and approaches for rock mass classification. In these lectures we have elaborated different geotechnical parameters like joint depth, joint spacing, joint aperture, joint opening, joint filling, joint persistence, joint sets, which will helpful in rock mass classification. And the rock mass classification is a partially semi-quantitative approach to quantify geological information for future engineering application. Further, we have discussed two approaches for rock mass classification, and these will be relevant for detailed discussion on rock mass characterization in our next class. Thank you.